Hello guys, I'd like to do a little video on how the basic terms we use for uh, in a basic solar system. So we know that, for example, the Milky Way galaxy has, I think it's over 100 billion stars, and therefore they all have their planets and stuff. And I just want to help clarify what these different terms we use within science. So, for example, generally a solar system will have a star. Now, the star in our solar system is the sun. So, if I put a little thing here, say star, so if I put there, star, so yeah, star, it usually occupies the centre of where all the gas and dust was joining together when the star was being made. So now we have the star. Now, not all star systems or solar systems will have planets. Probably some will have a few, some will have loads. It depends on the circumstances of the actual site of the area. So, but typically we have something called planets. So a planet is an object that has a certain size. Usually, it has to be quite, big-ish, and it needs to have like a spherical um, shape, and that's what we call planets. There's probably a size or limit where it becomes a planet. As if you know, for example, in science, we have dwarf planets as well, which are quite mini versions of like big planets that like Earth. Because Pluto's a lot smaller than Earth. So yeah. So we know that. So generally, the planets orbit the star. Now this orbit doesn't have to be circular. It can be. It can be. What is it? It can be like an oval. So if we get another one, this is another planet, and this goes in like a weird oval shape. Uh, I think this is what a lot of planets generally do in the exoplanets. Like it's quite good. It's quite unusual. Why, like for example, in our solar system, we have a lot of circular orbits. They're not perfectly circular, but they are generally pretty much circular. Like very very small like differences between the ratios. So yeah, in fact, I will put if I put just to tell you. So these are planets. So yeah, these are planets. They orbit the star. So yeah, we also have something called the moons. So if we have, so if we have this little, so about that size. Generally, a moon is a natural satellite that orbits a planet. So when you think about satellites that we have in space that mankind sends up, generally they're artificial satellites. But the natural satellites is, for example, the like the moon, for example, because that was already there before man was there. So that's why we call it a natural satellite. So if we show the orbit, it goes around. This orbit can vary, of course, depending on the circumstances. So if you actually, if we put moon. Now, generally, for example, with Earth, we only have one moon, but there's a lot of planets out there, like for example in our solar system, where like Jupiter or Saturn will have like multiple moons, a few dozen actually. If you think about, like for example, Titan, that's one moon that orbits one of these gas giants. So yeah, moons are a sort of general thing that we expect in a in a solar system. Now, what also we have, which is we have in our solar system, we have like an asteroid belt. No, the asteroid belt, oh, is basically where there's a lot of like residue or stuff left over from when the solar system was being formed. So it can be these meteors. Basically, they don't have a perfect spherical shape. They are, because they're very small, they have a rigid shape, and therefore, because they're really small, they won't form a perfect sphere. These asteroids can have a variety of different chemicals in them, organic, inorganic, etc. They're usually quite a good supply of different things for the planets in the solar system. For example, sometimes they might have water in, yeah. So yeah, that can be useful. So yeah, if I put like a little, yeah, if I put let's call it it's a bit small. That if I move that down there, and then I can. Yeah. If I do this instead, this might be better. Yeah, there we go. So yeah, this is the asteroid belt, the leftovers from the formation of the solar system. How many billions of years ago? So another one we generally have, sometimes we have gas giants. Now gas giants are unusually large. They are unusually large planets compared to, like, for example, a rocky planet like this one here, like Earth or Mars, for example. So generally they are quite big. They're not as big as the star itself, or they could be. It depends on the system, but generally, generally they are quite big. You know, tens or hundreds of times larger than a typical rocky planet. So if I put, so yeah, a gas giant. Now the gas giants can have moons and stuff that go around them, like with Jupiter and Saturn. Jupiter and Saturn are gas giants, so, and they have lots of moons. So yeah, generally gas giants, they don't really have a solid surface. It's a lot of gas and dust in a turbulent, very densely packed together in a turbulent motion around the planet. In fact, gas giants are quite unusual to us because you can't really go in them, because if you send satellites down there, generally it will get destroyed because it's so like turbulent and dangerous that it's so easy to get destroyed. So they are mysterious to us in a sense. So yeah, they are. So yeah, but yeah, generally rocky planets, for example, when we're looking in our solar system, they're quite easy to observe and study about. So yeah, I think that's it. Yeah, we also have comets, for example, as well. Now comets, like the Halley comet, for example, they generally have their own orbits around the sun sometimes. They might have something like that. Very weird orbits, obviously, because they are very small, but they also have a lot of propagation. They are going at a very high speed. So yeah, yeah. They're also, like, for example, in our solar system, we have something. I'm not sure. It's this kind of cloud that exists. I'm not sure what it's called again, but yeah, it's on the outskirts of our solar system. There's all this gas and dust that was left over from the actual formation of the star. This is gas and dust mainly, and in our solar system we have a Pluto. We have Pluto. You know, Pluto actually goes into that. I think I'm not sure what it's called again, but I'll you should be able to find it easily on the internet. But generally, it's where all the leftover gas and dust is. There's not really meteors is, but there's generally that's where all the comets come from, because that's where there's a lot of, like, for example, ice and dust and stuff. So yeah, hopefully this was helpful to give you an overview. This is very basic, but generally these are how the structures of a lot of solar systems are. It's not always like this. Like, for example, with gas giants, you do get some gas giants that are really close into star. They're literally, like, really close. I've heard about them in different systems in the solar system. They are very fascinating systems, I have to say. So, but yeah, there's a lot to learn about X other solar systems and stuff, and what we can learn. So yeah, hopefully this was helpful. Yeah, if you have any more suggestions, please leave them in the comments. Or if you have any questions, just ask me. And I hope you have a good day, and I hope you take care. See you later.